Well, hi. We're gonna resolve this problem of torsion. That is the exercise number one. Our problem says if it's known there is a hole with a diameter of 0.4 inches has been drilled in shafts A, B, C, and C and D, determine the letter A that says the shaft in which the maximum shear stress occurs. B. The magnitude of such stress. And we have the answers like just to reference. Uh, the way how we're gonna resolve this problem is a way that is easier for me. So, who first steps we have to identify formula and data. For example, here says that we have a diameter of 0.4 inches. So we're gonna use it. And uh, we know that we're gonna calculate the maximum stress and that we're gonna calculate our inertia moment. Uh, so the second part for me is draw a diagram, just for reference about the first image. And then how you can see, I draw the three circles and to identify where we have the points like A and B, C, and D. So we're gonna change all of diameters that we have because our formula to work with it, we need the value of the radio. But how we know the radio is just the half of a diameter. So in the between the point A and between the point B, we have our diameter of zero point 0.8 inches. So if we calculated the half, we're gonna have a result of zero point 0.4 inches that we uh, mark here. And in the second BNC, 1 inches, the half is 0.5 inches. And the third C and D, we have a diameter of 1.2 inches, so we're gonna have a result of zero point 0.6 inches. Well, the third step is change data informally. How we can notice, we know all the values that we can use for this formula. So, to calculate the magnitude, we have to find first our inertia moment. Between in 8 and B, to calculate it, we have to substitute all of data. So remember that the first radio is our exterior radio, and the second that appears here is the interior radio. So when we multiply this data, we have a result of 0.03 inches to the fourth power. Then, with this data, we can complete the next formula, that is to calculate the maximum stress, where you can notice that we uses the quantity that we're gonna uh, mark with blue. That is this part of here. We have 800 levers, 2 inches. That is the first torque that we have here. I'm gonna put the little T1, T2, and T3. In this way, we're gonna can know what torque is for formula for to substitute. But this is, remember that you then with the you have this result, you have to multiply it for the radio that is represented with a little c. Then we're gonna divide it by the j, that is our moment in hertz that we calculate before. So this gives us a result of 8,648.6 648 levers per inches to the square. And then we're gonna continue the step number 3, that is change the data that we have in the radios. How you can notice it's stereo radio again, interior radio, and this gives us a result of 0.095 inches to the for power. BC also is the same. We have to change our data here, but how you can notice the torque that we used to multiply here was obtained by a simple rest in this part where we have the torque in B and C, where we just obtain the result. So we substitute, we multiply it and divide it by a result of chase, and this gives us a result of 8,000 425.052 levels per inches to square. That this represents the same, I think. For the to calculate the J and the maximum stress and the point C and D, we have to do the same. But for don't confuses, we're gonna mark all this data in color black. For the you can notice. We calculate the torque in C and D, and the same way that we calculate the torque in B and C. So we're gonna make the same. We're gonna substitute exterior radio, interior radio, that gives us a result of 0.201 inches to the 4 power, and then we have to calculate the maximum stress. That is the formula again that we have here. That is multiplied our torque multiplied by the radio between J. That gives us a result of 7,761.194 levels per inches to square. Then also we know that it's the same the unit here. Well, it's not the same. We have to recreate the point just 1, 2, 3 steps. Then, for conclusions, to analyze the point A and B, we have an observation important here. We collect all the results in this part, so we can analyze, and just is to analyze what quantity is biggest, and then how we can notice we have biggest the letter AB. That's the point with biggest stress, with maximum shear stress. So for the letter A, we can conclude that the answer is AB, where is happen the maximum shear stress. And for letter B, just have to add the value that give us. So we're gonna put just the value that give us that was 8.648, and we convert. Remember that we convert this unit levels per inch square to these units. Remember, just we move the numbers. So this is all my explanation. I hope you can understand, and thank you. Well, hi. We're gonna resolve this problem of torsion. That is the